The first thing we're going to talk about in 6.5 is dividing polynomials. Now we've added polynomials, 4x squared plus 6x squared. We've subtracted them. We've even multiplied them, something like 4x times the quantity of 2x plus 7. We've done this stuff, but we haven't divided yet. Now, before we get into division, start off with a quick warm-up. And this warm-up is going to go old school. I'm talking super old school. How old school, Smith? How about 42 divided by 84,625? That's right, long division old school. Go ahead and long divide this. Go ahead and press pause and then check your answer. All right. We're going to go super old school here. Multiply by 2 on both sides. First, oh my goodness. Let me start over. How many times does 42 go into 8? It can't. So you move on to the 4. How many times does 42 go into 84? Goes in there twice. So 2 times 42 is 84. And then you're going to subtract these. 84 minus 4 is 0. Then you bring the 6 down. Bring the 6. How many times does 42 go into 6? It can't. 0 times, which means that you have to bring down the next term. 2. So how many times does 42 go into 62? Goes in there once. So 1 times 42 is 42. We're going to subtract these again. And we're left with 20. And then you bring down the last term. Bring down the 5. How many times does 42 go into 205? You might want a calculator for that and multiply 42 until you get close without going over to 205, just like the Price is Right. Happens to be about 4 times. 4 times 2 is 8. 168. And when you subtract this, we're subtracting, we get 37. All right? Look how old school this is going to go. So, we're at the end of 84,625, but rather than doing a decimal point and bringing down a 0, 37 is our remainder. So we're going to call this remainder 37. Man, remember that in 3rd grade? You started talking about remainders, and then you got moved on to decimals and fractions and never saw remainder again. Well, here it is. It's come back. So here's the thing. 84,625 divided by 42. Our answer is 2,014. And the remainder we can change into a fraction or a mixed number here. We get 2,014 and 37/42ths. That's our final answer here. The remainder can be turned into a fraction. So here's the thing. We're going to follow the same procedure, the same stuff we did with long division with dividing polynomials. All right, so let's do our first example here. Number 1, we're going to divide y to the 4th plus 2y squared minus y plus 5. We're going to divide that by y squared minus y plus 1. Okay, so we're dividing this by y squared minus y plus 1. Whatever you're dividing by, that is what's outside. So I'm going to put in y squared minus y plus 1 outside. And we're going to divide. Now here's the thing. We got y to the 4th, y squared, y, and a single thing. If you look closely, something's missing, isn't it? Let's start writing this in. We got y to the 4th, but we don't have y to the 3rd. What would be the coefficient in front of y cubed such that it's gone? We're going to keep that 0y cubed. We need to have that as like a placeholder here. Plus 2y squared minus y plus 5. I'm going to make this black too. All right, so how many times can I get 3 terms into this 1 y to the 4th term? We can't. We can't get into 2 terms. We can't get into 3 terms. So I'm going to put my first thing above the 3rd term because there's 3 terms here. Now, the whole trick here is we got to get this first term to be exactly like the first term here. So what times y squared will give us y to the 4th? It'll be y squared again. So you're going to take y squared and multiply it by lottie-dottie everybody on the outside. So this is y to the 4th minus y to the 3rd plus y squared. And line it up beneath. Now here's the thing, just like when we long divided, we're going to subtract this from the term above. But here's the thing, when we subtract it, I don't know about you, I don't like subtraction. So I'm going to change this to plus and do the opposite of everything inside of here. Alright, so when I add this, what I've got now is y to the 4th plus negative y to the 4th, those cancel. That's the whole point there. 0y cubed plus 1y cubed is y cubed. 2y squared minus y squared is minus y squared. And we're done subtracting, so then we bring down the next term. The next term is minus y. All right, so now once again, we got to get y squared to look like 3y cubed. So I'm going to multiply by y. Y times y squared is y cubed minus y squared plus y. All right, good. So we're going to subtract these. Subtract this, but again, I don't like subtraction. That creeps me out. So I'm going to do add the opposite, opposite, opposite. And when I subtract these, the y cubes cancel. So you saw me pause because I was freaking out. You probably caught this beforehand, but weren't here to tell me. I made a mistake right here, didn't I? My bad. 2y squared plus negative y squared is positive y squared. My bad, guys. Fix that really quick. That should be plus y squared. And it's still minus y. Now this is going to make sense. Sorry, y'all, if you were confused there. The y cubes cancel. Plus 2y squared. The y cubes cancel, or excuse me, the y's cancel. Ah, there I go again, making a mistake. This is negative y plus negative y minus 2y. Bring down the, we're done subtracting, so we bring down the last term, plus 5. All right, pretty sure that this is right this time. All right, so again, first term look like the first term. So what do I got to do to y squared to make it look like 2y squared? We're going to multiply by 2 plus 2. So this is 2y squared minus 2y plus 2. But we're going to subtract these. And again, I don't like subtraction, so add the opposite, opposite, opposite. 2y squared cancels. Negative 2y plus 2y, those cancel as well. 5 plus negative 2 is 3. And that is our remainder because we're out of terms to drop down. This 3 is our remainder, which means this. Our final answer is just like we did up here. We took 2014 with a remainder. You take the remainder and divide it by what we divided by. So here's the thing. This is our answer is y squared plus y plus 2 plus 3 over what we divided by y squared minus y plus 1. That is our final answer here. So let's try another one just to make sure that we're getting this. next one we're going to do is we're going to divide x to the third minus x squared minus 2x plus 8 by, now here's the thing, we're going to do two problems here. Part A. Part A, we're going to divide by x minus 1. So, here's what's up here. X minus 1 divided by x to the third minus x squared minus 2x plus 8. All right, now make sure we got x and then no x. Then inside here we got x to the third, x squared, x to the 1, no x. So we don't need a place to keep it from getting weird. Let's get going here. We need to make x look like x cubed. So I'm going to multiply by x squared. Now, there's two terms, so we're going to be two terms in here. We're going to multiply by x squared. X squared times x, x to the third, minus x squared. Now, when we subtract this, remember, add the opposite. This is going to be the x cubes cancel, but check this out. Even the x squareds cancel. So, the x squareds cancel. So, next thing we need to do is bring down our negative 2x. Now, because there's no terms left from here, and there's two terms, I'm going to need to keep two terms. So not only does the negative 2x drop, but also the 8 drops, because I need two terms to multiply by. All right, so here's the thing. Because we couldn't do anything this time, there's actually a plus 0 here. But then I got to make x look like negative 2x. So I'm going to multiply by negative 2. Negative 2 times x is negative 2x plus 2. All right, and we're going to subtract this. But again, opposite. 2x's cancel. We're left with 6. So our final answer here is x squared minus 2 plus our remainder is 6. So it's 6 over x minus 1. All right, that one's tricky. Let's do another one. This is our final answer here. Part B, we're going to divide by x plus 2. We're going to divide by x plus 2. Oops, I'm going to move this away a little bit. So we're going to divide by x cubed minus x squared minus 2x plus 8. Okay. So, two terms in, so we're at the second term. Got to make x squared look like x cubed. So multiply by x squared. We got x to the third plus 2x squared. And we're going to subtract this. Add the opposite. X cubes cancel. We got negative 3x squared. Sorry, I'm going to change the color here. Negative 3x squared. Bring down the next term. Minus 2x. So we got two terms. How many times? What do I got to do to x to make it look like negative 3x squared? Multiply by negative 3x. So negative 3x times x, negative 3x squared, minus 6x, negative 3 times 2. And we're going to subtract this again. Add the opposite. And I'm left with the x squareds cancel. Negative 2x plus 6x is 4x. And we're going to bring down plus 8. What do I got to do to x to make it look like 4? Multiply it by 4. So now we're at 4x plus 8. But we're going to subtract this. And then add the opposite. So we have a remainder of 0. So how about that? When we divide this by x plus 2, our final answer is x squared minus 3x plus 4. With a remainder of 0, which means, well, that's the thing. Tell you what does that mean? What does a remainder of 0, what does that mean? Think about that. We'll talk about that later in this chapter. I'll tell you what. This is the last example. 2x to the fourth plus 3x to the third plus 5x minus 1 over x squared minus 2x plus 2. If you want, go ahead and try this. Press pause and try it. And then I'll have the answer up for you to check when you come back.
The final answer is 2x squared plus 7x plus 10 plus 11x minus 21 over x squared minus 2x plus 2. What? Shout out to Courtney, Kyle, Sydney, John, Jen, CJ. Woo!
And then spit out!